Namaskar. This is Eng Suraj Singh. I am continuing my discussions on building practice, building practice. This now says swimming pool details. I'll show it to you. This is a swimming pool plan. Swimming pool. This is 25 by 13 meters. You can see this. A comprehensive plan which is showing pool shelf and balance tank. Pool shelf and balance tank. This is a pool shelf. This is a balance tank, and this is the pool area. This is the deep end, and this is the shallow end, and there is a slope in between the two. And this is the pool side carpet. All the four walls are of RCC, and balance tank wall is also RCC. Balance tank is closed from the top. You can see the directional flow of water, and there is a ring main to balance tank. There are two manholes, access manholes on the balance tank, and you can also see a shade here for resting and shade pergola. This is the shade pergola. This is the shade, and this side is store, changing rooms, and treatment area, pump rooms, shaded area. This is a layout, swimming pool layout and services typical. The 3.2 meters maximum depth, 1.2 meters minimum depth, and size I am telling again, this is 25 meters to 13 meters. Very well, it is clear, and you can see there is a supply of water. These are the lines showing the supply of water. These points. And I'll show you the isometric now. This is the isometric of this tank of the swimming pool. This is three-dimensional isometric. It is showing how the water is supplied, how the water flows, all four sides, walls, main ring, you can say main ring of water supply. Also the balance tank and ladder, etc. And arrangement in the wall of the light. You can see this light, how this is fixed to the RCC walls. And here are different sections, details in RCC wall of the channel. You can see it like this. This is the channel from to which surface water can be withdrawn from. The PVC grating is fixed here in this channel here. This is the surface draining out water channel, and another detail of that. This is giving another detail now. Various types of channels are used, and these are the details. This arrow shows how the water moves and various. This is the two pump room. Water is leaving, and now this is the sections of RCC details. This is the drawing showing balance tank, and balance tank is here. The structural section, and there is a base slab, shelf slab. You can say shelf slab, pool shelf slab. This is the deeper end. This is the sloped end, and I am continuing to the next one. And this is that sloped end here, and shallow end here, shallow end, this is longitudinal section. Various types of details are given here. Blinding, bitumen, cement mortar, water slope, and protection. This is the swimming pool detail for better understanding. And if you see now the plan again, this is for the construction joints. This is for the construction joints. If you see the construction joints here, you can see this is the construction joint. This is another. This is another one. This is another one. This is another one. This is another one. This is deep end. This is shallow end. This is slope, and this is balance tank. And you can see the locations of the construction joints. So you can construct this portion one time, then you can construct this portion another time, then this portion another time, like this in sequence. You can construct. Not necessarily you construct one time. Construction can be done in sequences so that construction joints are established and formed. As well as you can see the section again where construction joints are shown. You can see here this is the construction joint elevation. This is the construction joint, and you see PVC water bar that is used at the construction joints. In these joints, you have to provide the water bars in various sections, straight way, straight shape, and in T shape. Welding is done for the T shape, or T shapes are available. This is T shape for the vertical member. This is T shape for the same plan member. This is used by welding process, plastic welding process on site. This is giving the positions of all construction joints, and that was about the swimming pool. Now I take you to various details of construction. Typical details you can say is the cavity valve. Cavity valve is very important in air conditioned buildings. There is a cavity valve here. You can see this is external blockwork valve and this is the internal blockwork valve. This is the external one and this is the internal one. There is a cavity in between, 50 mm cavity, or it could be 10 mm, 100 mm cavity. For example, I am showing 50 mm cavity. In this 50 mm, we have to fill polystyrene, extruded polystyrene, and this is blockwork. One blockwork is 200 mm thick. This is 100 mm thick. So 200 plus 100, 350. There are wall ties in between at various spacing, say 1 meter spacing or 75 mm spacing, 75 centimeter spacing. So this external wall, this internal wall, this is cavity, and the whole is there is the cavity. Wall ties are fixed, and this is called cavity wall. This is used for the external locations. And now it's another one. This is roofing. Roofing, as I told you in my last discussion, that this is inverted roof system. This is a slab, roof slab. This is a parapet, and here this is a roof slab is given here. Roof slab. These are roof tiles here. These are the roof tiles. Roof tiles, and this is resting on polystyrene board, which is further resting on waterproof membrane, and which is further resting on foam concrete. And this is the system, and here is the skirting and aluminum flashing for solar reflection. This is regarding roofing, and this is guaranteed for 10 years minimum. Now I'll show you the foundations. You see these foundations. This is the blinding concrete. Above that is RCC footing with steel is shown, and this is the step column portion, and then there is a flooring here. There is a protection membrane on the surface and protection membrane for the concrete, and then there is a protection for the protection membrane. And you can see this again, a kind of grade slab, a kind of floor. You can see this is blinding concrete. This is grade slab. There is a flooring on that, and starting and moment joint. It is typical, and you can see I just should wall joint. This is a wall, and this is the column. There is a joint here by a tie, that's called wall tie. By short firing, it is fixed. Where there's a different material, there's a RCC wall and column. There's a connection. Wall connection is called to RCC columns. And again, waterproofing as absolutely first last time. And various details here. You can say again various details here. I am moving slowly so that it is clearly visible. And furthermore, in India, generally in the roofing, mud first is used according to CPW specifications. That is what I have reflected here. Roof slab and then bitumen layer and mud first and over this roof tile. Small roof tiles they use in our country, but I just include for the purpose of information and for nothing else. Otherwise, in hot countries where air conditioning is a requirement. Now I'll show. Now I'm giving details of rebar, reinforcement bars. There are various shapes of reinforcement bars. For example, I'm taking these shapes. You can see here various shapes. This is one shape. There's a straight bar also. This is one shape here. You can see this shape here. This is the shape of steel. And there's another shape here. Generally, this is used for chairs. And there's another shape here. Ring. This is for the ring. And this also for the ring. Other one. This is, you can say, a kind of U shape. This is chair. This is a ring. This is another ring. And this is the shape for the column vertical position from the foundations to top. Another one is straight shape. This is a straight shape. This is L shape. L shape, and this is U shape. This is U shape. Then another one. This. And this is the curved shape here. Curved bending. Then there is different type of shapes are there. These shapes are used generally in buildings. Generally, these are used in buildings. Many of these. BS 4466 or 8466 gives the code for these shapes, and there are various notations on that. For example, the straight shape is given 20 number there, 61 is given for the ring, and 41, 99, like that. There are so many shapes, 38. I'm not referring to that, but just for information purpose. I'm here narrating here. Again, you can see on this page the same kind of shape arrangement, but on different sides, different position style. You can say hook and hook on both sides and continuous bar in between, and then circle for the column, round column. And there is a ring extending bars. Again, that one, and again the same type. Then L shape, which is generally used in foundations, vertical columns. This is again the shape, and then there is obtuse angles, and this is prefabricated welded wire mesh, which we call the BRC generally, as BRC is a company, but I'm not referring to the company here. It is welded wire mesh, WWF mesh, welded wire fabric. There are various notations for this mesh, and these could be 8 mm, 10 mm, 6 mm. Shapes are 8, 152 for example, or anything like that. 150 spacing or 200 spacing. Generally, these are used in the field as such. We'll go to the next one. Now I'm giving you some visible imaginary details how the steel looks, how the steel shall look after fixing. You can see this here. This is a drawing which is giving typical general reinforcement provisions in a simple structure of buildings from practical viewpoint, and this is the foundation portion. You can see this is a mesh here. This is continuing here. Strap this. This is column stub column here, stub column portion. In the foundation you can see the bars in both directions. Similarly here the rings and bars. In this strap there are rings, it's like a beam, it's like a cantilever. This is a cantilever footing design. This one, and on this are resting stub columns steel. This is all stub column steel, and above that is next level column which is going up to here. Next level column which is going up to here. This is footing. This is the footing. Footing seen here. You can very well see this footing. On this footing, then there is beam here, strap beam, and this column above the step column goes, and it meets with the details of the rebars of the beams with the slab, and there you can see so many chairs are arranged there. Chairs, as I showed to you the shape of the chair. These are the chairs. These are the chairs, the beam. These are continuous rebars of column, and these are slab rebars. The rebars I'm calling for reinforcing bars, so please don't get confused. This is very important from appraising yourself. I'll move to the wall reinforcement. See this drawing, this sketch. There are two columns, and this is one column, this is other column. There's a between these columns there is a wall reinforcement, and there's a kicker here. You can see this column and kicker and notations. You see the notations. And this is another column. The wall is between the two columns. This is the steel of the wall steel. This is the wall steel. This wall steel, you can see from the kicker there are smaller bars. These are the smaller bars from the kicker, and then these are the main rotating bars upwards. Notice given there may be some rebars not straight, to be made good to straight position while fixing. There it is shown here. Position while fixing upper extensions for preparation. This is what the mean is. And take to, and you see this is the scabbled surface here. This is scabbled surface. This scabbled surface, scabbled means chip surface, head surface. This all is scabbled surface. I'll take you to another one now. This is slab. You can see this, a complicated arrangement. This is another complicated arrangement. Maybe I take it closer so that you can see easily. This is the column. This is the column, and these are typical reinforcement details of a wall with openings, and also added proposed slab reinforcement arrangements on side, not done in one go but step by step or by levels, provided for idea only here. Maybe this was prepared manually, and you can see how much work was done on this without computer. And spacing of this strap shall vary depending on the variation in the shear stresses in the beam design. Strictly follow engineer's details, and noting is given on that. You can see slab beam, slab reinforcement as well. And I'll now go to the other sketch. and that is for a wall fascia. This is steel details for a wall fascia provided with window at the both ends with RCC columns. There you had seen an opening here. This was the opening in the last discussion. And in this is the sketch. This is the sketch. It is off now. I will take it down for the purpose of showing to you. This is the down purpose. Well, I am standing also. You are to be listening to many voices. We don't care for that. So there is a sketch. You are focusing on the sketch, not on my voice particularly. So there is a plane moving above my house, and you can see this. There is a car as well. On the have kept this book, and this external view you can see here. The grass. Just for relieving you from the stress I give to you. Where is again reach to this place. Sun is on my head now. You can see this. This is the details of wheels. All parts here. Scanning. Again I am taking it up for your reference. So you can see it clear. I'll take it to the next sketch, next level. There's another one. You can see this. This is arrangement for a fascia beam. Any two columns. You can see this is a fascia beam. Fascia beam and two columns. Beam reinforcement for indication only. For the purpose. Again, next one. This is existing structure for slab around the proposed column. This is the column here, and this is the still of beams here. You can see the beams. The beams. This is actually I'm trying to indicate about column, beams, and slab. How can be imaginarily viewed? Because these details are not available in any book. Just for your information. Another detail. Same. You can see this. Here it is for typical reinforcement detail for the cross-shaped column. Column cross-shaped, and you can see the details arrangement, detailed arrangements here. All chairs. You can see the chairs at various locations. Chairs at various locations. Chairs are supporting steel members. And then this is typical reinforcement details for a proposed pentagonal column. There is pentagon column, pentagon here, and this is a steel raising up. This is RCC slab, structural floor level. It's rising here and moving upwards. Now go to another one. This is hexagonal, 6 sides hexagonal. Hexagonal column. Hexagonal column. Hexagonal column. And same slab. Slab. And the details. This is chair here, same as before. And next step is for octagonal column. Octagonal column is existing slab and kicker of the column, steel reinforcement of the column, chairs, slab reinforcement, all as shown before. You see various twice. This is another footing slab, footing detail of reverse footing, ordinary footing. This is tension footing. Tension means steel member. Sorry, this is the footing below, and this is actually footing for a structural steel frame member, vertical member, tension we call it. And this is very light steel here. Size is 160 by 160. Footing size. And there is a groove here, written groove for the anchor bolts. And dotted line is showing the size of the foundation. We'll go to another one. That is combined footing, simple combined footing, rectangular combined footing, rectangular combined footing. Rectangular. You can see it this way. It will better. This is one column. And this is another column. Both are columns that will be combined. And this is the footing. Here. Some tractor is passing by. You will get the voice. Unfortunately, well, because speech is not that much in this, so I selected to focus on the video outside my room, and I'm standing outside now. This is the steel of combined footing. You can see various rings, 8-legged and 12-legged, as required in combined footings. 8-legged and 12-legged. And this is the arrangement shown here. Sorry, while I was there. So I'll go to the next page. That is again a big arrangement. Lift well. I showed to you before the lift shutters. Now this is the lift steel. The steel is the lift steel. I see this are the walls, and this is the wall top. You can see the walls, all 4 walls. All 4 walls giving very congested steel, and you can see a kicker below. There's a kicker below here. Very congested steel on the existing slab is shown. Existing slab. And we'll go to stair now. Stair arrangement. This is like that. The arrangement of stair. You can see that. The stair. This is the arrangement. It's not very clear, but for the purpose of education only. And move to certain architectural sketches which were which are going to be included in next video. For more information, you can say the combined drawing of combined isometric of shapes like Satya swastik with cruciform. You see this is swastik and this is cruciform. Similarly, this is cruciform here. One swastik is centered and four cruciforms are extended around with roads. This is a typical imaginary arrangement for residential building. After that, I'll show you another, that is pentagon. Pentagon is also for residential building. Pentagon. You have seen that pentagon. Then, as I showed to you before, again I will show you that T, which is better than the previous sketch. T's and a house isometric. House isometric, you can say house isometric here, showing all sides. I'll take you to another one, another drawing of the same isometric. You can see this. You can see shaded area. You can see all windows, terrace, and columns, balconies, front lawn. This is the next one, and after this, I think this was the arrangements I showed to you. Next video will cover many more details. Many more details shall be covered in the next video.